In this class I am going to discuss problem 4. Find the partial differential equation of all spheres of radius 3 units having their centers on the xy plane. Now let me take you back to the page where I have discussed different sorts of spheres of radius and their centers lying on different planes. So let me discuss the first equation. Equation of sphere with center A, B, C and radius R is given by x minus a whole square plus y minus b whole square plus equal to r square. Now the second equation of the sphere with center xy plane means the z coordinate is 0. So A, B and 0, this will be the center and the equation will be x minus a whole square plus y minus b whole square plus z square equal to r square. The third equation is of the sphere with center on yz plane. When you have yz plane, that means x is 0, b, c, and the equation will be x square y minus b whole square z minus c whole square equal to r square. The third equation is find the equation of the sphere with center on xz plane, that means there is no y coordinate. So a, 0, c, this will be the equation and the equation is x minus a whole square y square z minus c whole square equal to r square. Now with the center, this is the equation of that sphere. Now what if the centers are lying on x axis? Now let me take you back to another page. Here I am going to discuss spheres with centers lying on axis. Now here in the first equation I am going to discuss the general equation where the center is ABC and radius is R, x minus a whole square, y minus b whole square, z minus c whole square equal to r square. Now the second equation is where center is on x axis, that means there is no y value and z value. So a, 0, 0. So the equation will be x minus a whole square plus y square plus z square equal to r square. Now what about the third equation where the center is lying on the z axis? So when you have the center lying on z axis, that means there is no x value, there is no y value, we have only the z value. The equation will be x square plus y square plus z minus c whole square equal to r square. Now what about this equation of sphere with center on y axis? That means there is no x value, y value we have and there is no z value. Now what will be the equation of this particular sphere? It is x square y minus b whole square plus z square equal to r square. Now let us solve the problems. So here what is the equation of sphere of radius 3 units having their centers on the xy plane? Now let me discuss the solution. So the solution is, so we have a sphere lying on with center on the xy plane. That means what will be the center of this sphere? The centers will be, since it is xy plane, so a, b, 0. And what is the radius? Radius is 3 units. So this is the center of that sphere. Now let us write the equation of the sphere. So the equation of the sphere will be x minus a whole square plus y minus b whole square plus z square equal to 3 square. So this is the equation. So now what we have to do is check for the number of arbitrary constants and the number of independent variables. So let us call this given equation as equation number 1. Now how many arbitrary constants do we have in this equation? Only 2, a and b. So n is equal to 2 number of arbitrary constants. What about number of independent variables? How many independent variables we have here? X and y. Z is treated as a function of x and y. So m is equal to 2. And what is the relation between them? They both are same. So n is equal to m. So when you have a equal relation, that means we will get a first order partial differential equation. So for a first order partial differential equation, what you need to do is we have to find P as well as Q. So from the given equation, equation number 1, now let us differentiate this partially with respect to x. So differentiating equation 1 partially with respect to x. So after differentiating this partially with respect to x, you get 2 into x minus a plus, what is the derivative of second term? Y is constant, b is constant, so 0, plus what is the derivative of z square? It is 2z into dou z by dou x. So the derivative of 9 is 0. So in short, you can write it as 2 into x minus a plus 2z into, what is dou z by dou x? It is p. So bring the terms and then simplify. So you get 2zp is minus 2 into x minus a. You can cancel the terms too and bring the minus in the RHS to the LHS. So minus pz is nothing but x minus a. So you got another relation, call that as equation number 2. Now similarly, what you have to do is differentiating equation 1 partially with respect to y. So when you differentiate partially with respect to y, you know x is constant, a is constant, so the derivative of this is 0. So 0 plus, now what is the derivative of y minus b whole square? We are differentiating with respect to y. So 2 into y minus b, and then y minus b you have to differentiate again, which is nothing but 1. We have done the similar problem in our previous classes. Plus, what is the differentiation of z square? 2z into dou z by dou y equal to 0. Now let us simplify this further, which is 2 into y minus b plus 2z. What is dou z by dou y? It is q equal to 0. Now in short we can write, simplify this further. It is a similar problem we have discussed in our problem 2. You can go through my previous videos if you want to know how exactly this is being done. After simplifying this, you get 2zq is minus 2 into y minus b. After cancelling the terms 2 and 2, you get minus qz. Bring the minus in the right hand side to the left hand side. You will get it as y minus b. Call this as equation number 3. Now we have got, I told you our equation is only a first order equation. So these equations are enough. We have to find only p and q, that is enough. So we have got 3 equations. Now let me rewrite the equation. Our equation was x minus a whole square plus y minus b whole square plus z square equal to 9. This was our equation. Now we have to find a relation between these 3 equations 1, 2, 3 in such a way that we have to eliminate the arbitrary constants a, b, c. Okay. So one way of thinking how to solve this problem is by substitution. We can substitute equation 2 and 3 in this equation. So after substituting, What is x minus a? X minus a is minus pz. So minus pz whole square plus y minus b. From our equation 3, y minus b is minus qz whole square plus z square equal to 9, which is nothing but p square z square plus q square z square plus z square equal to 9. Thus, we have got our partial differential equation, which is a first order partial differential equation but without any arbitrary constants. I think you have found this problem useful. You can try various sorts of different spheres having their centers lying on different axes as well as different planes. You can work all the problems by yourselves. Thank you.